Nitrogen triiodide is a molecular compound made up of nitrogen and iodine. What I'm going to do for the first step is determining how many valence electrons are going to be available for bonding in this molecule. And as we'll see, there will be some electrons that are not going to be involved in bonding. Nevertheless, we must actually first of all figure out how many valence electrons are present. So here goes. Well, in this compound, the nitrogen triiodide, we have one nitrogen, three iodines. So what we need to do is we need to look at a periodic table and get the number of valence electrons for each atom. Using a simplified periodic table that I show you how to create in an earlier video, we've got one nitrogen, and we have three iodines. Now, how many valence electrons does each of these atoms have? Well, it turns out that the nitrogen has 5 valence electrons because it is in group 5A, and each of the iodines has 7 valence electrons, being group 7A. On a normal periodic table, the nitrogen in nitrogen triiodide is located here on the periodic table, and the iodine in the formula nitrogen triiodide is located there. The nitrogen is located in group 5A, so it has 5 valence electrons. The iodine is located in group 7A, so each iodine has 7 valence electrons. I am going to do a tally of the valence electrons present in nitrogen triiodide. Now, each nitrogen has 5 valence electrons. Each iodine has 7 valence electrons, but there's 3 of them, so I go 3 times 7. Figure out the number of valence electrons brought to the table by iodine. Now do a tally. 1 times 5 is 5, 3 times 7 is 21. There's a total of 26 valence electrons available for bonding. Now, what I'm going to do is I'm going to put down the nitrogen as the central atom, and I'm going to put each iodine down around the central atom. The next step in the process is to connect the iodine to the nitrogen with a single bond, remembering that a single bond represents the sharing of a pair of electrons. So I'm going to just put little dots representing electrons on these lines. Now, what I have to do is make sure the outside atoms are happy. Now, each of the outside atoms wants to have 8 electrons. It must have 8 valence electrons around it. This iodine here sees 2. So it wants 8, so it gets 6 more. Same deal here. This iodine sees 2, wants 8, gets 6 more. And again, this last iodine gets 6 more electron dots. Well, what about the central atom, the nitrogen? Well, how many dots does it see? Well, the nitrogen sees 2, 4, 6. Well, that's very interesting. You see, all of the atoms have to have 8 valence electrons around them. The nitrogen, however, only has 6. We need to force it to have 8 electrons. So what I'm going to do is I'm going to stick an extra 2 electrons there on the nitrogen. These are non-bonding electrons. These are electrons not involved in chemical bonding. They're there on the central atom, but they're not actually bonded to any atom. So let's just do a tally. How many electron dots do we have down here? Well, we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and 2 more from the non-bonding pair of electrons in the nitrogen. 24 plus 2 is 26. We have 26 electron dots down on our diagram, and we had 26 valence electrons to distribute. So this is, once again, a happy Lewis electron dot diagram.